So welcome. So this session is going to be on Aerospike automation. My name is Shakthi Kannan. So when it comes to automation, you have a huge number of tools that are available to you. Some are free and open source software, some are commercial, and some use a procedural syntax, some use a declarative syntax. So in this training session, we're going to look at some of these examples from a provisioning, configuration, and monitoring perspective. So fundamentally, there are two models that are available. One is the push-based technique, so where you have a control node or a bastion host from which you can deploy and configure your Aerospike server. The second approach is a pull-based approach where you have a client, like Chef for example, which runs on the Aerospike database server, and it pulls the required state that you want to be in from a Chef master server. Now, the choice of tools depends on a lot of factors, the ease of installation that it provides, the kind of security that you want, the number of clusters that you have, how much you want to scale, the simplicity, do you need to learn a specific language in order to describe your infrastructure, the scope of your automation, do you want to have a full-fledged automation system or do you want to keep something manual? But you can also use hybrid approaches. Like for example, you can use a push setup for provisioning your machines, and then you can use a pull setup for the configuration. Of course, it also depends on the teams and the workflows that you have. Some enterprises have separate DevOps and NOC teams. So it depends on what they are comfortable as well. So the first thing we're going to talk about is inventory management. So I'm going to take Ansible as an example here. So the Ansible way of doing things is simplicity, readability, and using declarative syntax. So they basically use YAML files, and these YAML files are human readable, and any person should be able to write those. And the way you want to structure your project layout or directory structure is an example here. So here we have the different files. It could be the scripts or the configuration files that you want to deploy, and then you have your inventory. So this example, we are considering 3 Aerospike clusters, and per Aerospike cluster, you have a folder. Okay, so this is an example of a dynamic inventory in AWS. And then you have your playbooks. So Ansible calls them as playbooks. Chef calls them as recipes. So what you actually do here is you have separate folders to do different tasks. So you might have administrative or maintenance tasks that you want to do. You want to provision machines. You want to configure them, and so on. So this gives you a clear separation of what you want to do. The playbooks inside these directories have the details on how you want to do things. And this inventory gives you a list of where you want to run these configurations. So you're basically separating what you want to do, how you want to do, and where you want to do it. So with inventory management comes inventory groups. So when you're starting, let's say you're testing an Aerospike server, you will have a cluster of nodes. You might have some web applications. So these represents the inventory groups. And then you might deploy in different regions, so be AWS East or AWS West. Accordingly, you have those nomenclatures. And then you might have your meta definitions where you have a staging environment and a production environment. So depending on what you want to do, where you want to do it, and when do you want to do it, you can run your playbooks across DBs or web applications or across regions or according to what purpose that you want to operate with. So of course, these are some good practices. Having these playbooks in place which are well tested and validated and which you want to repeat often, it helps to reduce human error. And once you're building these playbooks, you'll see a few examples. There are some best practices that you can actually follow. Right. So in the push-based setup, which is quite common, so we have the bastion node setup. So this is the entry point for maybe some of your ops or system administrators, which needs to be tightly access controlled, so you can use multi-factor authentication. And once you are logged in to this Bastion host. From here, you can run your playbooks to manage your clusters and web applications. Okay, this is a very common approach. Some people call it as a control node as well. Again, this is a push-based setup. Right, so let's go over this example. So here we have under playbooks, under the provision folder, we are provisioning an Aerospike server in AWS. So I have a name for the playbook. I'm running it locally, but I'm provisioning it in AWS. I'm having a tag for this playbook, and I have the list of tasks. Now, the best practice here for Ansible with the YAML syntax is have vertical definitions, give enough white spacing so it's more readable. So here they have different modules defined. So in this EC2 group, we can define, in this example, we are creating a security group for Aerospike. So I want to make sure that 3000 to 3003 ports are available. We're able to SSH into the machine, and this 8081 is for the Aerospike management console. 4333 is for TLS. Right? So when you are provisioning, one first step could be to have the security group defined. Right? So this is quite readable. Now I have hard-coded these values like region, these numbers as magic numbers. But what the Ansible styling allows you to do is abstract them into variables. Okay? And then you can run the same thing across to a different region. Right? So again here, have consistent tagging, use names, give enough white space so it's readable. And since these are plain text files, you can version control them. Use something like GitHub where you can store them. And the way you want to develop these specific playbooks is to start with small tasks like these, test them, validate them, and slowly build on top of this knowledge. So you have a very iterative process when you develop these playbooks. The other advantage of doing this in a playbook fashion is you have more control of your infrastructure. So continuing this, then we launch the instance. Again, this is the EC2 module that Ansible provides you with. You can specify the instance type, the key name that you want to use. If you have a pre-built image, Ronan mentioned Amazon Linux 2. So you find the image that is available in your region. You can insert that. Then all the subnet information. And then you add the instances and you wait for the SSH server to come up, and so that you can then log into the instance and do the next configuration steps. So this is just a small example of a playbook for just provisioning an instance. Okay, so try to have these small playbooks which do one thing, follow the Unix principle, do one thing and do it well. And of course, most of these YAML files can be parsed in text editors, so it's quite readable. And try to have smoke test built in. So you also validate that whenever you do a particular change in the infrastructure, let's say you're starting an Aerospike server, make sure it's listening on port 3000, for example. So that is an example of AWS. Of course, we also support Kubernetes. So here you have a Kubernetes master, which has its own set of functionality, which has schedulers, controller managers, and the etcd database. And with the API server, you can create pods. So we generally recommend stateful sets. I'll just give you an example demo on this, where you have your Aerospike server running in a Docker container, and then you have locally attached storage. Okay. The rest of the Kubernetes components are there. So there's a good documentation available in our site. So let me quickly switch to a demo. So here is the text clear at the back. Is this clear? Can you see it at the back? Okay. So Minikube is a single node VM which has an entire Kubernetes cluster. You can use it for local testing. It's not production ready, but it's good for testing on your laptop. So hence I have set this up here. I have provisioned 3 pods. So this is KVM. and running the Minikube VM here, so I can SSH into the Kubernetes cluster. Okay. Yeah, it comes with its own kernel, and basically it's running Docker and all of the etcd, the Kubernetes controllers, the schedulers, etc. Okay. So again, in Kubernetes we have the use of the YAML file as a pod specification. So you can actually see the Minikube running. This is a single node, and then I can show you the 3 pods that are running. Each one is having a local storage. Those are the private IP addresses, and of course I can use ASADM tool to connect to this. So if you see the IP address of the Minikube, it's running on 39.210, right? So I have exported the service on 31,000 port number, and this is a single node cluster. So I have to do this. And then if I do the usual info call, let me zoom out a bit. So you will see the cluster size is 3. We have those 3 pods that are running in this. Again, this is available in our GitHub page. Just search for Aerospike Kubernetes, you will find this. The Minikube also comes with a dashboard. So if I do let me move this. Okay. So we have those 3 pods which are running, and if I scroll down, I see the stateful sets and services. So again, I use a service port, so I have an external reference to port 3000. And of course, you can click on the information on nodes, persistence, volumes, etc. So you have to define a config map. So these are the persistent volume claims, which are, each one of those is bound to the individual pod. This is the Minikube information, persistent volumes. Okay. So the GitHub page has information on deploying this on AWS as well as in the Google Marketplace. So you can try this out. Okay. Let's go back to the presentation. So there was provisioning. So continuing with configuration. So this is a simple example where once you have provisioned an N node machines in AWS, you want to form a cluster. So most public cloud infrastructure do not allow you to use multicast. So the only way you have to go about is setting up a mesh cluster. So here we have an example. So I'm going to run this on the nodes, which is the inventory group that represents the AWS machines that we have just launched. Okay, and so I have a configuration file which I'll show you next. So we have these tasks. So again, for each task you name them, and when you see in the output of the Ansible invocation, we will see how these are useful. So we stop any Aerospike service, we copy this configuration file, and then we just start the server. So this is a part of the configuration file. Again, if you see the directory structure, we have files and templates. So you're neatly organizing and separating the files from the playbooks from the inventory. Okay. So we use the J2 template format in Ansible, and here we have to specify the other node's IP addresses. So you have a simple for loop that goes in, and like any programming language, you can use variable substitution, you can do conditionals, control structures, and do iterations like the for loop. So this will basically set up the mesh cluster on those AWS machines. This is another example of configuration using Puppet. Puppet uses a master agent setup. So when you provision an Aerospike cluster, you have a Puppet agent that is installed. So what it does is it will send information about itself as facts to the Puppet master. So information like the operating system, Aerospike server version, and all that. And then the Puppet master prepares a catalog. So here, example here, let's say you have different functionality defined for Aerospike, for XDR, and so on, right? So you have those modules defined, and then depending on the node that you are going to form a cluster with, you can specify what modules you want to include, what configuration changes you want. So this is compiled and sent as a catalog to the actual Aerospike server. It runs the catalog functionality, executes the changes, and then it sends the report back to the Puppet master. This way it makes sure that it synchronizes with what the Puppet master expects it to be in. Of course, you can have, this is a Ruby domain-specific language syntax. So if you want to use Puppet or even Chef, you need to be familiar with this language. Again, it depends on what tool your team is comfortable with and what they want to use. So this is another example of deploying Aerospike and configuring this with Puppet. So most of these tools also allow you to extend the functionality. They do come with code built-in modules, like the EC2 example that we have seen. But sometimes you want to extend that. So here's an example where under playbooks at the admin folder, we have a script. Basically, this we use to get the name and IP addresses of those machines. Just an example. But you have a lot of these callback functions that you can implement. Since Ansible is written in Python, you have all of these support for these types of plugins that you can implement depending on what functionality you want to do. So this actually we use it in the training. So once we set up the instances, I get the names of the participants and the IP addresses, which we shared during the training sessions. So this is just the Python script. So when you actually run a playbook, this will basically call this get names and IPs function here. It will just print the names and IP addresses of the participants. So most of these tools have the ability to extend the functionality to what you want to do. Okay. But it's recommended that you first try to see if you have a built-in module that you can reuse. Okay. And then you can, if it's not there, then you can proceed to write your own. Similarly for Puppet, they do have a Aerospike module written by one Tube Mogul. It's quite popular. It's available as open source in their Puppet Forge repository. So. Other things that you can use are like scripting. Let's say that you want to get a collect info logs from your Aerospike server. And these are things that you do periodically, and you can automate this. So again, you're running it on those Aerospike machines, and here just call ascdm-e collect info as the command module output. So the basic syntax of Ansible output is, if it's a green, it's good, there's no change. If it's yellow, then it's something is modified, and if you see a red, it means something has failed. One important property of all of these deployment scripts is idempotency. A number of times you run a playbook and you want to synchronize your infrastructure to the state that you want to do, it should still maintain the whole state. Okay. So again, when you're writing these playbooks, make sure you enforce the style that you want to follow, version control these playbooks in a Git repository. Try to refactor and modularize. It helps to keep the playbooks more meaningful. And once you have a lot of functionality, you can break them into what are called as roles. And you can share those roles between different teams. It's quite extensible in that context. Yeah, documentation is pretty good for most of these tools, and definitely recommend reading that. So not everything is command line based. If you like a single click install, there are front end tools that you can use. So here we have Rundeck, where you can actually define the steps that you want to run. So you can have those playbooks written, you can have configuration parameters defined, and then once you execute those, you'll get a summary report, and then you can also set up cron-like jobs which can be run periodically. And these tools also have API support. So if you want to build your own JavaScript front-end client, which will internally invoke the Rundeck for those job executions, you can do that as well. This is for a single-click install type of graphical user interface approach. Yeah, so upgrades. This is again documented from the Aerospike page. So you want to stop the Aerospike service. You make sure you download the package that you want to upgrade to, and then you do the actual upgrade, and then you restart the Aerospike server, and then you want to make sure that things are stable before you want to upgrade the next set of servers. Now, the checks can differ depending on from which version to which version you are doing an upgrade. So I have a small demo here. So I have a 3 CentOS 7 virtual machines running, and let me just okay. So this is using again KVM. Let me zoom out a bit. So again, cluster size is 3. We are on 44014. So I use the mesh configuration setup to install this and set up the cluster. So what I want to do is just to show you a quick example of the upgrade. So let me just we break this into 2. Okay. So here I can I have the KVM inventory. I'll show you these files after this demo. And then I have an upgrade server script. I'm going to increase the verbosity, so you can use up to 4 Vs. So if you want to have more verbose output. So the idea here is on all of these machines, I have downloaded a specific version of the Aerospike server package. So I'm going to stop the server, and then I'm going to install the package. Okay. And then I'm going to start the server, and then I'm going to check for cluster stable condition. And when the condition is okay, then I proceed with the next node. So we're going to do it in a very serial process. So it first starts with AS1, and I can keep checking the info command here. Yeah. The This node has upgraded to 4521, and then we move on to AS2. We have two nodes upgraded to 4521, and this will be the last node. Once it's done, you will see that. Okay. So now if I rerun the info command, we should have all of these nodes upgraded to 4521. Okay. This is a simple example. Let me just quickly show you the file. Yeah, it's a simple example. So I have the nodes defined as those three machines. I'm just stopping the server, extracting this package, installing the server, starting it, and then waiting for the server to listen on port 3000. And then we just do the cluster stable check command. But of course, we can add more checks as required. So when you set up the monitoring stack, it's important that you go through the same process that you use for the Aerospike machines. So you want to provision nodes for whatever tools that you want to set up, configure them, and make sure that you have the Aerospike logs feeding data into these monitoring stacks. So there are a lot of tools available. You can do collectd or statsd, and then you can use like asgraphite. It's a Python script. Pump the log data into Aerospike, and then you can view the output in Grafana dashboards. Of course, you have other tools like Nagios and Zabbix, which you can use. A lot of these connectors are available as open source, so you can actually use them. But the same process of developing the playbooks for your Aerospike servers need to be followed for the monitoring stack as well. And that's all I had, and I think we have time for questions.
During the update, you just stopped the server, upgraded the Aerospike, and started again, waiting for the port. But what about, for example, waiting for the migrations to complete or something like that?
Yeah, we could add those checks. So this is just to give you a demonstration example here, but you could add those checks as well. I think the cluster. Let me show you the documentation for this. So if you go to the Aerospike docs upgrade page, they actually give you the list of checks that you need to do. And the cluster stable check is one of those. So there is an upgrade path. So for every release that we make, there are release notes which actually tell you what needs to be checked before you do the upgrade. Okay. I'm just opening the documentation for this. Right. So these are the basic steps that I followed. Download the package, stop the service, upgrade to latest package, and then you install the package, start the service, okay, depending on systemd or, and then so you can basically check for these conditions like use ASADM or ASInfo, check those values in your playbook, make sure that all those conditions are satisfied, and then you proceed to do with the upgrade for the next node. So yeah, this is for 4 or 3 onwards, you have this clusters table which can be used to check those conditions. But again, we are trying to use more checks in order to ensure that you have a smooth experience when you upgrade Aerospike. That's the key to it. Right? But yeah, a lot of these things can be automated. And it's quite useful, especially if you have large clusters you want to manage. Somebody else, yeah.
What do we do? What should we be doing when we take nodes in and out of the cluster? Like there are a seed set of say 3 nodes, and mesh IPs are right there in the Aerospike farm. But then I add a 4th one, and maybe take down the very first one. Should I be looking at the scripts, updating the Aerospike concept into these machines, or?
So it depends on like what tool you are using. So some people use Console, KONSUL, which is like a service discovery thing where you can register your nodes to that and you can query that and then use that as a key value pair to get the node IP addresses and then use that to update the configuration file. So you might want to look up some service discovery tools like that as part of your whole deployment stack.
Would be to make sure the Aerospike conf files are updated to reflect the current setup.
Yes. Basically, you need just 2 or more IP addresses. You don't need to have all the cluster IP addresses in the configuration. Because Aerospike is chatty, you've heard of the gossip protocol. So it will be able to discover the other nodes in the cluster. But yeah, some deployments we use Console. It's a pretty good tool for discovering other nodes. But again, if you're using the kind of the Puppet or Chef setup, you already have the master catalog. You already have provisioned the nodes, you already have the information about each and every node. So once you prepare the catalog, you can just pull it to the new provisioned node and then you can update the configuration file. Somebody else had a question?